Hi, in this video I'm going to demonstrate a simple deadlock in the Java programming language, and we're going to show you how you could detect whether your program has a deadlock or not. So in front of me I have the Wikipedia article on deadlock. So in summary, in concurrent computing, a deadlock is a state in which each member of a group is waiting for some other member to take action, such as sending a message or, more commonly, releasing a lock. Deadlock is a common problem in multiprocessing systems, parallel computing, and distributed systems where software and hardware locks are used to handle shared resources and implement process synchronization. Okay, so if you've learned anything about creating threads in your program and having those threads acquire a lock in order to execute a critical section of code, then you probably have some familiarity with this concept already. But if you don't, hang tight and we will jump right into it and demonstrate a deadlock in about 50 lines of code in Java. Okay, let's jump right into it. I'm going to create a new project. It's a Java project, and we're going to call it simple deadlock. Okay. And let's do this. So I'm going to create a new class called simple deadlock. Right. And let's go ahead and start with our main. Okay. And what I'm going to do here, I'm going to introduce first the two resources that are going to act as our locks: private static final object resource A is equal to new object, just a generic old object, private static final object resource B is equal to new object. Now that I have those two, I can start. So I'm going to say final runnable R1 is equal to new runnable, right? And in here, I'm just going to say system.out. Actually, let's fix the compiler first there. System.out.println. And we're going to say thread1 holding lock A. System.out.println thread1 waiting for lock B. Okay? And then we're going to run a method called wait for a while. We're going to give it 5,000 milliseconds. We'll write this method in a minute. And then we're going to say synchronized on resource resource A, right? Oh, actually, I messed up here. So once we enter this method, we want to say synchronize on resource A. Sorry about that. And right away, and then try to synchronize on resource B next. Okay? And then once we get in here, we should say system.out.println thread2 holding lock 1 and 2. And as we'll see when we do the printouts, we should actually never reach that point. Okay? And now we're going to copy this and just make some switches here. So here now we're going to call this R2, and we're going to say that R thread 2 holds lock B and waits on lock A. Okay, let's fix that. All right, A and B, right? And we need to write the, so let me format my code, a little bit ugly here. Okay. Let's see. Did I? I think I missed. There we go. Sorry about that, guys. And let's get rid of that. So that should be that runnable, and that should be the end of main, and then that should be the end of the class. Sometimes when you're programming on the fly, it can get really hard. So let's also, outside of our main method, let's declare a private static void wait for a while, final long wait time in millis, and let's just be really simple, try and catch interrupted exception B, and the try is just thread.sleep for wait time in millis. Okay. Right. So now we have that, and in our main, we're just going to fire up two threads. We're going to say final thread T1 is equal to new thread and give it the runnable R1, and final thread T2 is equal to new thread and give it the runnable R2, and we're going to say T1 dot start the thread and T2 dot start, right? And then we're going to have the main thread wait for T1 and T2 to finish, just in case. That's right. So T1 dot join and T2 dot join, and that's going to throw an exception. System dot out dot println we are done. We should never reach that point, right? And we need to handle this unaccepted exception. So I'm just going to add the signature here to our main method. And now I'm going to look at the warnings the IDE gives me. This could be converted into a lambda. Let's do that. Makes it look a little bit cleaner. More Java 8-esque. Same thing here. Replace with the lambda. And it looks like our code is formatted. So let's take a little bit of time to walk through this, right? And in fact, I'm actually going to change this 5 seconds to 6 seconds. So what's going to happen is here. This is what's going to happen. Thread 1 is going to run the R1 code. It's going to come in and immediately lock on resource A, right? And then it's going to come in here, do these print statements, and wait for 5 seconds, okay? Very shortly after thread 1 starts, let's say on the order of nanoseconds or milliseconds, thread 2 is also going to start. And thread 2, actually I didn't change the order of these. So thread 1 is going to it's going to lock on A and then try to lock on B. Thread 2 is going to lock on B and then try to lock on A. Okay, so I didn't, in my copy paste, I forgot to do the update there, right? So thread 1 is going to grab resource A lock and wait for 5 seconds. Meanwhile, resource B is going, thread R2, thread 2, is going to grab resource B, wait for 6 seconds, which is slightly longer than thread 1, right? We want to give thread 1 a head start so that it can reach this point and get, reach this point and get blocked out because thread 2 immediately got that resource. And then they're going to be in this deadly embrace situation where thread 1 has resource A and is trying to acquire resource B, but resource B was immediately taken by thread 2, and thread 2 is then going to try to get resource A, but guess what? That is taken by thread 1. So here we are in a deadly embrace. So we should run this, be able to run this program. It's 50 lines of code. And we see here that we're never going to print the messages out that show that we have lock A and B, right? And we're never going to show the message that we are done. We are in a deadly embrace, okay? And actually, the JVM is very smart. The Java language, the Java virtual machine can actually detect a deadlock. So what you can do here is I've taken a shortcut. I can run my program on the command line instead of in the IDE. And if I send it a signal on my Macintosh, it's command backslash. That is the sig quit signal, right? I can actually get a thread dump. It's actually it's, I'm sorry, it's control backslash, not command, control backslash on my Mac. I can see here, look at this, found one deadlock, right? And we can see the thread states in our program. And if you know how to read this, it's basically telling you what's going on. It's saying that thread 1 is waiting to lock a monitor that has some sort of address, and thread 0, and it's telling you it's held by thread 0. Thread 0 is waiting to lock on some monitor which is held by thread 1, and we're never going to be able to get out of this. We're in a deadly embrace. Okay, so that's it for this week. Please do comment and like and share the videos, and I will see you guys very soon. Thanks.